In this video, we will start with a simple scatter plot and then convert this into marginal plots. Density marginal plot, a histogram, a box plot, and a violin plot. And this is a grouped density, grouped histogram, grouped box plot, and grouped violin plots. So if this is of interest to you, then keep on watching. So let's see how we can convert a simple scatter plot into a marginal plot. Marginal plots carry much more information than a simple scatter plot. So these are the libraries which we're going to use in our project today: ggExtra, ggPLOT2, and then GT. We'll use the built-in data set called empty cars. We would use the MPG, or miles per gallon, and displacement, DISP columns, and we'll create a simple scatter chart out of this. And here is the magic which ggExtra performs. So the simple plot is converted into a density marginal plot, a histogram marginal plot, a box plot marginal plot, and a violin marginal plot. So by default, it will produce a density plot, so like this. So we saw that by using the ggMarginal command, the x-axis as well as the y-axis gets a marginal plot, but you can control it this way. So I'm just saying that I want the margins on the x-axis. So all these density, histogram, violin, box plot, etc. gets plotted on x-axis only. And if we can do it only for x-axis, we can similarly do it only for y-axis also. So margins equals y. So let's create another plot with all the bells and whistles. So in the new chart, we're going to put some colors in there. So color based on the factor of the cylinder, and increasing the size of the points, putting the legend at the bottom, putting the name of the color legend as number of cylinders, the title at the top, the subtitle below the main title, and then the caption which goes below the chart. And then finally put some colors there for different number of cylinders. So here is the final chart. So we can see that the data is grouped based on the number of cylinders. You can see different colors. So this is going to be a base chart, and we'll try to enhance this into marginal plots now. So apart from creating a marginal plot, ggExtra has some nice features also which we're going to use in our plots. So for example, I'm going to rotate the x-axis labels by giving different angles. By default, the angle is 90. You can control it obviously. One thing I noted was that there's no rotate text Y feature in this. Some more adjustments to our chart. We could use the HJust, or horizontal justification, and by giving the values, increasing values to HJust the positive values, it will move towards the left, and if we start giving negative values, it will start moving towards the right side. So you can see that when I increase the justification, you can see the movement much more clearly. So you can see that now the text is moving towards the right of the notches. Similarly, we can move our x-axis labels upwards or downwards using the V justification, or the vertical justification. Giving the positive values is moving it towards up, and then giving negative values will start pushing it down. Now we will see how we can do grouped marginal charts on each axis. For example, we just saw one marginal chart, like one density plot or one box plot on one axis, but now we can color them differently so that we get different colored bar charts, box plots, violin plots, and each representing the number of cylinders. So each color represents different number of cylinders, 4, 6, and 8, etc. So the color command only gives the color on the outside or the boundary of the plot. For example, you can see the violin plot boundary itself is blue or red, but the inside is white. We can also change the color of the inside by using the fill commands. So we can get nicely filled histogram, box plot, violin plot, And of course you can combine the color as well as the field commands together in one single line. So what next? We can also control the other parameters. For example, for x-axis, we call it x parameters or x params, and we can specify the bin width, and we can also specify the color of the fill. So you can see that different colors are being filled in, different bin widths are being used for the x as well as the y histograms in this case. So now we will see how we can control the size of the plots also. So for example, this is a basic plot, and I'm going to change the size to 1. Let's see what happens. And now size to 0.5 and the size to 0.1. The main plot starts getting smaller and smaller. And if I start increasing the size, you can see that the main chart becomes bigger and the marginal plots gets smaller and smaller. So you can find out what you want and then play with the size. But the default is pretty good as well. So I hope you found this information useful and practical. Thank you very much for watching it, and I'll see you in the next one.